Okay, today we're going to look at continuity. And I am going to list you the rules for continuity. This is something you must memorize. It will start showing up on memory quizzes. Okay, a function is continuous at c being some x value, if the following three conditions a function is continuous at some x value c if the following three conditions are met. 1, f of c is defined. 2, the limit as x approaches c of f of x exists, which thereby, just by that existing, that means the limit from the left equals the limit from the right. And, well, if the limit exists, the limit from the left equals the limit from the right. 3, the limit as x approaches c of f of x is equivalent to the y value. So what that means is, this means at point C, it has a y value. So when x equals c, the first one means there is a y value. There is a limit. And the y value equals the limit. Okay, those are very important, but here's the thing. You have to know them in math speak. Get it memorized. Okay, now we're going to talk about discontinuity. We have two different types. You have removable as in a whole. As in a whole. And then you have non-removable. Usually meaning an asymptote. Okay. You will get questions like, discuss the continuity. Number 1 is f of x equals 1 over x. Well, the first thing we want to do is we want to figure out if it has an asymptote. So we're going to set the denominator equal to 0. So I have an asymptote at x equals 0. And if you remember the graph of 1 over x, this is a parent function. It's just a racetrack graph. Okay? So at x equals 0, that is very clearly non-removable. And you have a asymptote at x equals 0. Another example you could have is f of x squared minus 1 over x plus 1. Let's factor my top and my bottom. Alright, so now I have x plus 1, x minus 1, or x plus 1. Well, my x plus 1's cancel. When that happens, that means I have a whole. A whole, and at whatever value makes that 0, so in this case, when x equals negative 1. So a graph like that would look like this. Alright, and then what's left? Well, what's left is just x minus 1. So I'm going to draw the line of x minus 1. Let's see if I can make a neater graph than that. Alright, well, if it's at x minus 1, my y-intercept is down here at 1. Okay, and it's just up 1 over 1, up 1 over 1. So connect my 3 dots, and then remember at negative 1 I have a hole. So it is roughly a line that looks like this, and just has a hole in the middle. So what you would tell me is a hole at x equals negative 1, which is removable. So in those types of problems, you are just going to list for me, is it removable, is it non-removable? Discontinuity. And you tell me why. Well, the first one I had an asymptote, and the second one I have a hole. Okay. Now, let's look at x equals, okay, another example of what we had earlier, or in the last video we watched. So on example 3, alright, I am going to have f of x equals the absolute value of x minus 3 and x minus 3. Well, what we learned yesterday, if we have a absolute value function like this, or something similar, it means that I am going to have a graph that at 3, the values are 1 and negative 1. On the negative 1 side, it points in the negative direction. On the positive side, it points in the positive direction. It's at negative 1. So I have non-removable discontinuity. And you tell me at x equaling 3. So when x is 3. Now, I could have another type of example show up, and this is a very, very, very popular AP question. It's one you need to know and be aware of. All right. So, for example,